So the rightmost column is the right side values, and the other columns are coefficients of different variables in different equations, right? Side. You try to convert this into a reduced echelon form. We saw the complete procedure in the previous session. You first choose the first column as the first pivot column, and its top element as the pivot position. Since it is 0, you use row interchange the first and the third row, and then make the
دخلت محمد
underlying entries
ادخل مال الرياضيات معود
of the pivot position 0. So these two should be 0. We already saw this
يلا
procedure
كيف أكرر كذا
in the previous
يلا ماشي
session. So the first column is formed as a pivot column. Then you cover the first row and move to the second column, and it's a pivot column, and make this its top element, which is this one, is a pivot position. So make this underlying entry 0, something like that. And then after finding a pivot position in the first and second row, you just cover them or ignore them or delete them. So in the resulting matrix, you jump over 0 columns, and this is the first non-zero column, which is a pivot column, and make the entries underlying the top entry 0, which is no entry, and this is in the this matrix is in the echelon form. So you apply backward steps like this. So this is pivot position, this is pivot position, and this is pivot position. The values in pivot position should be 1, and the entries above pivot position should be 0. We already saw how to do this. And in the end, over here, you have this matrix, which is in the reduced echelon form. This is pivot position, this is pivot position, this is pivot position. So each value in a pivot position is 1, and values below and above pivot positions are 0. You see, right? And this column corresponds to right side value. So after this, after extracting this reduced echelon form, you notice that no contradiction occurred. So it has at least one solution. So the first column is basic variable. What about the second column, x2? Is it basic or not?
Yes, doctor, it is basic.
It is basic. What about x3? It is basic or it is free?
The third column and the fourth column are not basic, are free.
Exactly, these two are free. And the fifth column, what about it?
Basic.
It is basic. So you have x1, x2, and x5 basic. x3 and x4 free. So you write, for example, x1 in terms of x3 and x4 and minus 24. So it means you write x1 as x1 equals minus 2. Sorry, x1 plus minus 2 x3 plus 3 x4 equals minus 24. And also for the second row, you have x2 minus 2 times x3 plus 2 times x4 equals minus 7. And for the third row, you have x5 equals 4. Right? So in this form, you have each basic variable in terms of right side values and 3 variables. This means solving a system of linear equations. So then you can give any arbitrary value to a free variable and find the corresponding values of basic variables. Right? Okay, let's move to the next series of slides. So, first, what is a vector? You think what is a vector?
One column.
One column or one row. It's mean only one dimension.
Exactly, a vector is a matrix which has only one column. A matrix with only one column is called a vector. So each vector in R2 has one column and 2 rows, something like this. This is a vector in R2. In general, a vector in Rn has n entries, n rows, and one column. Right? So a vector in Rn is something like this. W1, then W2, W3, etc. Wn. Right? Unfortunately, it's not easy to write here. So it's a vector like this. A vector in Rn has n entries, very simple. A vector in Rn has n entries. A vector in R3, how many entries does it have? A vector in R3.
3 entries.
Exactly, 3 entries. So, two vectors are equal if and only if, first, they have the same number of entries. Second, their corresponding entries are the same. So, right, so they have the same number of entries and corresponding entries are the same. Their first entries are equal, their second entries are equal, and so on. How do you sum two vectors? So you have two vectors, vector u and vector v. How do you sum them up? How do you sum up two vectors?
By adding corresponding u and v.
Exactly. You sum up corresponding entries in u and v. So you sum up the first entry of u with the first entry of v. You sum the second entry of u with the second entry of v, and etc. You sum the last entry of u with the last entry of v. Very simple. The next question is, how do you
Could you write
multiply?
example, please, doctor?
Okay, if I can write here, So you have a vector like 1, -1, and 2. It is defined in what space? In R3. And you have another vector like 7, 1, and 1. You want to sum these two vectors. What is the answer? What is the answer? 1 plus 7 gives you 8.
8. 0.
-1 plus 1 means gives you 0. And 2 plus 1 gives you
3.
3. So this is the result. 803 is the result. Right?
No, it's okay.
Okay.
Okay, Doctor. Okay.
So the next operation is multiplication of a scalar, a number, in a vector. How do you do this? You have a
By multiply each entry in U by C or by V.
exactly, you have a vector like U and you have a scalar like C. What does this mean? Multiplication of scalar C in vector U. As your friend pointed out, it means C is multiplied to each entry of U. C is multiplied to the first entry of U, then the second entry of U, and etc. to the last entry of U. Right? The result is a vector in the same space as U. In the result, each entry is the multiplication of C in the corresponding entry of U.
Doctor, C here is represent a constant variable, a constant value.
Yes, exactly. It is a constant value. It's like it's a number, a single number. Okay.
Okay, Doctor.
So let's give you an example. So you have two vectors U and V. U is 1 minus 2, V is 2 minus 5. You first want to find for U. What does this mean? What is this? What is for U?
Multiply 4 by the vector U.
So what is the resulting?
4 and
What is
minus
the
8.
result?
4 minus 8.
Exactly. 4 times 1 gives 4. And 4 times minus 2 gives minus 8. And now find minus 3 times of V.
Minus 6, 15.
Exactly. Minus 3 times 2, minus 6. Minus 3 times minus 5 plus 15. Now you compute you compute 4 times of U plus minus 3 times of V. Something like this. So you sum 4 times of U with minus 3 times of V. It's like this: 4 minus 8 plus minus 6, 15, which gives you minus 2, 7. Here?
Yes, right.
Appreciate that.
Okay.
Okay, Dr. Zakir, please, can you allow another student in this class?
Okay.
Thank you.
So
Thank you, Doctor.
you're welcome. Each point in R2 each point corresponds to a vector, and each vector corresponds to a point. So you have a other students. So you have a one-to-one correspondence between vectors and points in R2. For example, this is R2, right? And this is a point. This is your point. What is the vector corresponding to this point?
A and B crossing, right?
What is A and what is B?
Which numbers we have?
3, 1, right?
3 and 1. 3 on
Exactly.
X
So
and
3 and
1
X.
and 1 over Y.
Exactly. 3, 1, 2, 3, and 1 over Y. So each point corresponds to a vector, and each vector corresponds to exactly one point. So what is the vector? 3, 1 is a vector like this. A vector C1, C2, etc., Cp are called weights of this linear equation, linear combination, are called weights of this linear combination. Let me add your friend. Some of students leave the group and then they come back. Okay, so let me give you an example of this linear combination. We have this A1, which is a vector in what space?
R3.
In what space is defined A1?
R3.
Exactly. R3. And you also have this vector A2 in what space? R3
Also R3.
again.
R3.
Exactly. And you have this vector B like this. 7, 4, minus 3. This is also in R3. So the question is B a linear combination of A1 and A2? In other words, can you write B in terms of a linear equation of A1 and A2? So this is the question. Can you write B in terms of a linear equation of A1 and A2? So this means, are there scalars x1 and x2, numbers or weights x1 and x2, so that x1 a1 plus x2 a2 gives b? Do there exist such scalars x1 and x2 so that x1 a1 plus x2 a2 gives b? What do you think? Do there exist numbers or scalars x1 and x2 such that x1 times a1 plus x2 times a2 gives you b? If we have such numbers x1 and x2, then we can write b in a linear combination of a1 and a2. What do you think? Do there exist such x1 and x2 so that b equals x1 a1 plus x2 a2? So b becomes a linear combination of a1 and a2.
So I it's vector, and x it's a value, right? It's a weight.
Exactly, the scalar. So a value is called a scalar. Just a single number is called a scalar. A1 is a vector, x1 is a scalar. A scalar. x2 is a scalar, is a number, is a value, what you say, but it is better to call it a scalar because it is a standard name for it. A2 is a vector. B is also a vector. So can you write vector B in terms of a linear combination of A1 and A2? What do you think?
Doctor, so the question is to find the weight of x1 and x2?
The weights x1 and x2 so that x1 a1 plus x2 a2 yields b. Yes, exactly. What are the values for x1?
And convert, Doctor, convert the vector to linear
It's supposed to be
combination.
1, doctor.
Exactly. Yes, you are right. So let's work on this equation. So we have x1, which is a scalar, and we have a1, which is this vector, and we have x2, which is a scalar, and we have this vector a2, and the result should be b, a vector like this. Okay, and you know what is x1 times this vector? X1 times the first entry, x1 times the second entry, and x1 times the third entry. So this is like this. x1 minus 2x1 and minus 5x1. And also x2 times this vector is like this. x2, 2x2, 5x2, 6x2, something like this. Sum of these two vectors should equal b, like this, right? And then you sum
That's
these two vectors, and this is the resulting vector, should be equal to b. And what does mean equality of these two vectors? What does it mean?
It means
the
augmented
first
matrix.
entry of, this means the corresponding entries should be equal. The first entry of this vector x1 plus 2x2 should be equal to 7. So you should have something like this. The second entry minus 2 times x1, 5x2 should be equal to 4. So something like this. And the third entry minus 5x1 plus 6x2 should be equal to minus 3. So something like this. So what does this mean? This means we have a system of linear equations. What are the variables of this system? Are these two weights, x1 and x2? And what are the coefficients of this system of linear equations? The coefficient of x1 is vector a1, and the coefficient of x2 is 2, 5, 6, vector a2. And what is the right value? B is vector b. So we should solve this system of linear equations and see if there exist values for x1 and x2, right? In order to understand if B can be written in terms of linear equation, in order to understand if B can be written in the form of a linear combination of A1 and A2, we should solve this system of linear equations and see if there exists solution, at least one solution for this system of linear equation or not. At least one value for x1 and one value for x2, so that these equations hold. So, okay, solve this system of linear equations. You have this matrix. What is this matrix? This matrix is augmented matrix of this system of linear equations. 1, minus 2, minus 5, first column, 2, 5, 6, second column, and 7, 4, minus 3, the right side values, right? Then you convert this into reduced echelon form, which is something like this. So you tell me, is x1 basic or free?
Basic.
No, basic.
What about x2?
Also basic.
Basic.
Exactly. And we didn't encounter any contradiction. So this system of linear equations has at least one solution. Does it have many solutions or exactly one solution?
One solution.
Many
It
solutions.
has many solutions. Why one?
It has
No,
it
only
has
one. One
it has
solution.
exactly one solution.
One solution.
Because one solution, yes. Because
Why one
this the
solution,
third
Dr.
column because the third column is right side values, right? And we have two variables, x1, x2. And the column of x1 is pivot and the column of x2 is pivot. So we don't have non-pivot columns. So we don't have three variables. We just have basic variables,
ست
right?
آيات المايك ست آيات.
So the B, the rightmost column is B, right side values. We have two columns, one for x1 and one for x2. The column corresponding to x1 is pivot column. So x1 is basic. The column corresponding to x2 is pivot. So x2 is basic. So this means x1 is basic, x2 is basic. x1 is basic, x2 is basic. Because x1 has pivot position, x2 has pivot position. These two are for pivot columns. So we don't have three columns, three variables. Since we don't have three variables, we have exactly one solution. We don't have many solutions. In this solution, x1 equals to 3 and x2 equals to 2. So x1 is 3, x2 is 2. So 3 times of a1 plus 2 times of a2 gives you vector b. You can compute this and see that this holds. 3 times of a1 plus 2 times of a2 yields b. So b can be written in the form of a linear combination of a1 and a2, right? So you can write b as a linear combination of a1 and a2 because b, which is this vector, 7, 4 minus 3 equals 3 times of a1 plus 2 times of a2, right? Okay, let's stop here. If you have any question, please let me know.
Thank you very much.
Stay safe. Mike Mata.
Okay, so thank you and see you next week in person in the class.
إن شاء الله.
خدا نگهدار.
خدا نگهدار.
ممنون استاذ زنده
إن
باشید.
شاء الله.
الله
خدا حافظ.